Okay, today we're going to add on to what we talked about with simplifying exponents before. So now that you know how to combine them together in an expression, so for instance, if you know now how to do x squared times x to the fourth, and we talked a lot about how you go into and you do x plus 4, and that would give you x to the sixth. Then you have a situation where you have maybe x to the third raised to the fifth power. And in this situation, when the powers are stacked like that, then you multiply them. And so then now you would get x to the 15th. Okay, and we got into a lot harder problems than that, but that's just the basic gist of what you started with. So now let's talk about some other situations here. So we have a very important property where if you have anything raised to the 0 power, this is always equal to 1. So what's 375 raised to the 0 power? It equals 1. What's x plus 72 raised to the 0 power? Also equals 1. Anything raised to the 0 power equals 1. It's a great tool for when you're when things are reduced, and it is something that you do have to memorize. It's one of those properties that you just have to memorize. Okay, so anything raised to the 0 power equals 1. Okay, so now that you know that, let's erase this for a second. Okay, so that is one thing. Now let's talk about fractions and writing with fractions, and we'll associate this with the exponents in a minute here. So if I have the fraction, let's say that I have 2/3. I want you guys to get comfortable with turning 2/3 into a whole number. So what would you have to add to 2/3 to make it a whole number? We have 2/3, so if you add one more third, this will give you 3/3, which equals 1. Okay, now what about if it's, and you're going to move up to the next largest whole number. So for instance, if I have 5/2. Okay, what do I have to add to 5/2 to make it a whole number? Well, if I add, this is a bad example because I have 1 again, but I'll do another one that doesn't. If I add 1/2, the reason I want to do that is because that is going to give us 6/2, and that is equal to 3. And that was the closest one up. You do have to go one up. So let's do 3 sevenths. If I have 3/7 and I want to make this a whole number, what do I need to add to that? Okay, so what you're doing is you're making sure you have a common denominator, and then we want the numerators to add up to the same number as the denominator. Because if we can get 7/7, that equals 1. So here we would say, okay, well if we add 4/7, then that will give us 1. Likewise, if we have, for instance, 5/7, we already, or let's do even more than 5/7. Let's do, what I meant to do is, actually maybe let's do 6, not 6 because that doesn't work very good either. Sorry, that's what happens when I make it up as I go. Let's do 9/4. Okay, now when we go to make this 4/4, this is already higher than 4/4. So the next one that we would go up, we would want it to be 8/4. So you're taking this and timesing it by 2. 8/4, that would give, but this is still larger than that. So the next one up that we would do would be 12/4. So we'd want to add this 3 more. Now why 4, 8, and 12? Because those are the values that when you divide them by 4, they give you even whole numbers. Okay, so 9/4 plus 3/4 is 12/4, and 12 divides evenly when you divide it by 4 to give you 3. Okay, now this is an important concept for what we're doing. So when you're reducing exponential functions, it is not considered simplified until you have no negative function exponents. You cannot have negative exponents, and you cannot have fractional exponents. Okay, so no negative exponents and no fractional exponents. So for instance, if I have x to the negative 2 over x to the 3/2. Okay, this is not simplified because it still has more that can be done. First of all, this has to be a positive exponent. So how do we make that exponent positive? You move it to the denominator, right? So this becomes x squared. Now this, when we move that, what's left on top? Remember that it's always a 1 is left on top. You cannot put that as a 0. It makes the whole problem equal 0. Okay, it has to equal 1. When that gets moved, this is like it's multiplied by 1 up here. Okay, now we have this x to the 3/2 in the bottom. Well, we have to eliminate the x to the 3/2 in the bottom. Now, in the past, we've been able to manipulate fractions by multiplying the top and the bottom of a fraction by the same value. Like, for instance, when we make a common denominator. When you make a common denominator, that's what you're doing, is you're choosing something to multiply the denominator by, but then you also have to multiply the numerator by that same thing to keep the equality of the fraction. Rationalizing denominators. You multiply by the same thing on the top and the bottom, and so it still follows the rule. The same thing applies here. What we are going to find what we need to multiply x to the 3/2 by to make it a whole exponent. So remember, when you multiply together, you add their exponents. So what do we need to multiply this by to make it so that the exponents are whole? So here, this is 3/2. To get this up to the next whole number, we need to add one more half, because 3/2 plus 1/2 is 4/2, which is an even number of 2. So I'm going to multiply by x to the 1/2. But I now need to multiply the numerator by x to the 1/2 as well, so that I'm keeping the equality of my fraction. Okay, and then I go across and simplify. So here now I have x squared. These added together become x squared as well. And then on top, 1 times x to the 1/2. Okay. And then here we can add the bottoms together, so you get x to the 4th over x to the 1/2. So now that we have no negative exponents, we have no fractions in the denominator, we are all simplified. You could divide those. For right now, we're leaving answers like this, as long as there's no negative exponents and no fractional. Okay, so that kind of gives you, a taste of doing this. Let's see how much time. Let's do one more example. Okay, so we have, let's do this one. I'm going to take and throw a 0 in there. Let's do x to the 0 raised to the 3/2 powers over x to the 1/3 power and x to the 4/3 power. Okay, so first we're going to start by combining like terms, doing a little bit of what we learned before. So here, x to the 0 raised to the 3/2 power. Well, here you would multiply the powers together, which would give you 0, and x to the 0 equals 1. Okay, anything to the 0 equals 1. So remember these properties as you're doing this. This is the ones you still have to use from the last section. Okay, then here we're going to multiply these together. And when you multiply them together, you add their exponents. So I have 1/3 and 4/3. Now just a note, if they don't have the same denominator, you can make them common denominators when you're adding these together as well. So I have 1/3 and 4/3, which gives me 5/3. Okay, now what's the problem with this answer? Is there is a fraction in there's a fractional exponent in the denominator. Now, why does that matter? Because, just going back to the last lesson, this means that it has a root in the denominator, right? It's a third root of x. So it's essentially the same thing as rationalizing denominators by getting rid of any exponential exponents in denominators. Okay, so I just wanted to point out that that's why we're doing this, is because the same reason that you can't have the radicals in the denominator. If you have an exponential that is a fraction, it's like having a radical in the denominator. So we need to make this a whole number. So what do we need to multiply this by to make the exponents add up to a whole number? So this is 5/3. So the next whole number would be 6/3. So we need one more third. We can't just multiply the denominator by that. That changes the value of the function. But if we multiply the numerator by the same thing, this value is 1, and anything, so x to the third divided by x to the third is 1, and anything multiplied by 1 is itself, and that's why you can do this property. Okay, so then we are left with x to the 1/3 on top, and on the denominator we are left with x to the 6/3, which x to the 6/3 is the same thing as x squared, and on top we're left to x to the 1/3. Okay, great. We'll see you in class for assignment.